Kita mulai jam berapa Bu Fitri?
Jam 7 harusnya Pak.
Jam 7 ya. Baru 26 ya.
Iya.
Udah jam berapa tempat Ibu?
Jam 7:01.
Nah, sama. Nah, kita mulai aja Bu.
Oke.
Langsung Bu Fitri atau langsung saya gimana?
Silakan Pak Idra aja Pak.
Okay. Okay, good evening to all the Mr. Chin Lung Chen and all beloved students. This evening we will continue the second week atau second class of our lecturing. So this evening the lecturing will be delivered by the Mr. Chin Lung Chen as previously. So before the lecturing session, please all the microphone to mute setup. So if any question can put in the line platform or maybe in the chat room. So okay, so Mr. Chin Lung Chen, please, the time is yours.
Okay, thank you, Professor. Thank you. Good evening, everybody, and thank you for coming to class again. And then, so today, I'm gonna talk about the circular economy in wastewater treatment. And then, so I would like to share my screen. And then, so can anyone to help me to set up the screen sharing? Because right now I try to use a share screen function, but it says the host doesn't enable this function.
Permission granted, Dr. Chan.
Okay. And can anyone see the screen? See the PowerPoints?
Yes.
Okay. Okay, so first of all, today's class is gonna be a circular economy in wastewater treatment, and then so basically this class is gonna be focused on the wastewater treatment related to a circular economy. Okay, and then so there are 3 R's in the circular water economy. The first one is called reduce. The second is called recycle and reuse. And the third one is gonna be recover. Okay, so basically these 3 parts consist of the circular economy. And then so the first one for the reduced. The reduce means to improve water conservation and then water use efficiency and the management. And second, reuse and recycle is a water reuse for another purpose without treatment. And recycle is defined as the use of treated water for another purpose. And then the third one is a recycle. Recycle means we try to recycle some valuable material from the wastewater. For example, the energy. Second is a valuable material and the nutrient recover. For example, in Taiwan right now, there is one semiconductor company which is called Taiwan Semiconductor Manufacturing. We call TSMC. This company is in Taiwan. It has a huge wastewater quantity, and then this company is concerned about the environmental issue. So this company also try to recover some valuable material from the wastewater. For example, as you can see from this picture, this tubing is copper. Okay, so this because this company is wastewater containing high concentration of copper. So the company try to recover this copper from the wastewater, and then it can sell this copper in the market, and then so they can also try to reduce the heavy metal, for example, the copper into the river, and also they can sell this copper in the market. They can make some money. Okay, so this is basically just like they try to achieve the zero wastewater discharge. The zero wastewater discharge means there is no wastewater is discharged outside of this industry. Okay, because this company try to recover the wastewater, and then they try to treat the wastewater, and then send the wastewater back to the process, like a silicon wafer process procedure, and then so they try to recycle the water over and over. Okay, so in the wastewater in the TSMC, in this semiconductor factory, they didn't discharge the wastewater outside of the company. Okay. Okay, and then this is opportunity to implement the 3 Rs. So the first one is for community. The water-wise community inform the citizen who realize the rule they have in conserving water and associate resource. And the second is industrial field. So as a large water consumption, the manufacturer can bring a circular economy solution to scale, enhance the environmental risk awareness, and minimize environmental degradation. And the third one is wastewater treatment plant. So in the traditional, the linear economy, the wastewater treatment plant, they remove the pollutant. However, in the circular water economy, the copper will become the resource, and it can be recovered. Okay, so it means we will not waste the natural resource, for example, the copper, because copper is a natural resource. So if we don't recover this material in the future, the copper will be used up, and we will not have the copper to be used anymore. Okay, and then so let's take a look at the video. I would like to show you how does the company try to recover the copper from the wastewater. Okay. And can anyone see this video? Can anyone see? Okay. Okay, so this yellow color is the copper. So basically, this company used the kind of like use electrochemistry method try to recover the copper. Okay, so the copper is formed in the round shape, and then so this company just sell this copper directly to the market, and then the purity of this copper is about 99.9% of the purity. So it means they get a high purity of copper, and they can sell it as a good price. Okay. Okay. Okay, so basically this is how does the company try to recover some of the valuable resource from the wastewater, and then so because this this company have many it has high concentration of copper, so that's why they use electrochemistry try to recover the copper from the wastewater. And then so also actually not only just copper can be recycled. Some of the company they have high concentration of phosphate, or if they have high concentration of like a sulfate. So this company they are also try to recover the sulfate or phosphate from the water. So they can if when they recover the sulfate, they can sell the phosphate and then try to make it as a fertilizer. Okay, so when they sell the fertilizer to the market, they can make some profit. Okay, so it means they can reduce the cost of the wastewater treatment. Okay, because as everybody knows, being an environmental engineer, when we spend so much money to build up a wastewater treatment facility, and then usually the wastewater treatment facility it cannot make profit. The only thing the wastewater treatment facility can do is try to purify water. Basically, they try to make the dirty water become clean, and then without try to damage our environment. However, for a company, the owner of the company doesn't think in this way. The owner of the company always think about the money. They want to make some profit, right? So that's why if the using this wastewater, you can also try to recover some valuable material. It means it can lower your operation cost for your wastewater treatment process. Okay, so in Taiwan, right now, there are some companies they try to change the way how they do the wastewater treatment, meaning they try to recover some material from the wastewater. Okay. Okay, and then so here comes to drinking water treatment plan. Okay, and then drinking water treatment facility should be designed to process the same water quality with a high efficiency. Okay, and then the next one is for agriculture. The agriculture is one of the largest water user and contribute significantly to the water quality. So there are many opportunities for water quality improvement and value added or competitive product and service. Okay. And then for the new natural environment, the natural environment provides service is undervalued. For example, the nature-based solution in providing treatment, storage, buffer, and recreational solution need to be utilized. And then also for energy generation, establish a circular water economy require developing energy independence. And then it will use less energy and contribute a renewable energy to the grid. Okay. So as you can see from this image, this is the solar panel in Taiwan. Right now our government try to try to encourage the company try to use renewable energy. For example, the solar energy, because people think the solar energy is called a clean energy. So as soon as we have the solar panel in the set up in the ground, and then when we have a natural sunlight comes in, then the solar panel is able to collect, try to store the energy, then so we can use this energy to generate electricity. So it means, so in Taiwan, we have this type of the solar panel more and more often. And then actually in some of the family, you are able to see this solar panel on the roof of the house, because when you have this solar panel on the roof of your house, it will be collect the sunlight, and then also convert the sunlight into the electricity. So it means everybody started to use the clean energy, not just industrial. Okay, so right now we try to make our environment more and more clean, and then try to reduce pollutant into our environment. Okay, so right now here comes to the reduced. Okay, the first part. Okay, and then so first is water conservation and the water efficiency. So in the circular water economy aspect, the concept of the reduce is achieved through the water conservation and the water efficiency measure. Use less and the water efficiently. Okay, and then so what does use water efficiently? Because for example, in some industrial, they if for one purpose or procedure, if they only need 100 or about 100 liter of the water, then they don't need to use more than 1,000 water. Okay, so it means that we need to try to use the water kind of like in a smart way. Okay, we don't want to waste the natural resource of the water. Okay, and then the second is water conservation. Water conservation is very important when the water supply is low. Okay, such as during a dry season. Okay, in Taiwan, we don't have a dry season, because in Taiwan the temperature in Taiwan is very humid. Okay, but actually in some certain season we have a low water level. For example, in summer, the reason we have a little bit less water during the summer because the temperature is a little bit higher, and then so some of the water in the lake or in the reservoir, they will be kind of evaporate a little bit. And also in Taiwan right now, everybody try to have a very comfortable life. So almost every house we have the air conditioner. So when everybody use the air conditioner, the outside of the temperature will become higher. Okay, because the air conditioner try to keep the cold temperature inside, and then they try to move the hot air to the outside. So it will make the outside of the house become warmer or hotter. Okay, so when the temperature increased, the water in our environment, they will kind of evaporate a little bit. So it will make the water level a little bit lower. Okay. Okay, so this is water conservation and water efficiency. So we are going to talk about the four parts. The first part is called urban area, and then the second is for industrial, and then the third part is building, and then the fourth part is agriculture. Okay, and then so for the urban area, the first one is reducing water consumption and improving water usage efficiency is the key to short-term and long-term water usage issue. Okay, for example, in the drought season and the competition for limited water supply. Okay, because for example, in Taiwan we have so many cities, and then sometimes in some certain city, especially in summer, the water in less city, they will have less water. So at this moment, sometimes our government will kind of manage the water usage for some area which has a low water available. Okay, for example, sometimes our government will set up a limit. For example, from 10 a.m. to 11 a.m. Each building will only have a certain amount of water to be used. Okay, because we want to control people to use the water. We want people to use the water in a smart way. Try to save the water. Okay, and then second, in California, the resident can save their home water usage by 40 to 60% by repairing the leak and then installing the efficient appliances and the fixture and the replacing. Okay, and then lower water consumption and improving water efficiency at home can decrease the water usage and the lower energy bill. Okay, and then this is the data from the US. The toilet account for almost 1/3 of the average home indoor water consumption. Okay, and then the types of the family of four people use up about 30% of the water on maintaining the outdoor landscaping. And then the water heating can account for about 1/4, one quarter of the energy consumption at home. Okay, so for this part, they say they can save the home water usage by 40 to 60% by installing the efficient appliance. Okay, because actually, for example, I think this phenomena we are able to see in all the family. For example, sometimes the faucet doesn't hold water securely. So sometimes maybe in the kitchen or in the bathroom, you will see the water is kind of dropping. It's kind of dropping. Okay, so when the water is kind of dropping, like the water drops, even though it is very small, but in one day, when it accumulates for one day, this is kind of like a huge amount of the water. Okay, and then so in here it says the outdoor landscape. The outdoor landscape, just like for example the garden in the US, especially in the California, because the weather is very nice. I think in California there is only few days we will rain. For example, there are about 365 days in a year. I think there are about 10 days to 14 days, like one week or 2 weeks raining in California. Okay, so that's why California is very dry. And then and also people live in California, they prefer to have a garden around their house. So when people have a garden in their house, they will use a lot of water, right? They need a water to take care of the plant or vegetable or the flower. So that's why they say about 30% of the water on maintaining the outdoor landscaping. Okay. And then this is the case of Santa Cruz in California. The plumbing fixture retrofit regulation. Okay, so in this city, all the residents are required to be retrofit with a high efficient plumb fixture before sell the property. So it means the state government, they require the person, if you want to sell your house to other people, you need to follow this regulation. You need to have the high efficient of the plumbing fixture. Okay, and then so it says the seller must follow the following rules. First one, replace any toilet, and then urinal, and then the shower head. The shower head just like water comes out from the shower, and then so they do not meet the following low consumption standard. For example, there are some certain number they have to follow. Okay, so first one for the toilet, the toilet is 1.28 or 1.28 gallon per flush. Okay, so this is the regulation. And then for the UNO is about 0.5 gallon per flush. Okay, and then right now in Taiwan, actually we have a little bit more flexible option for the toilet. For example, we have two switch. If you are only just today, if you think you don't need that much water, you can use the one of the switch. Try to use just flush a little bit of the water. And then if you need a little bit more water, then you can use the second switch. Try to flush with more water. So actually in Taiwan we are also have similar rule, but actually we don't regulate the person who wanna sell the house. They need to follow this rule. Okay, for in Taiwan we just try to our government just try to recommend the family try to use this kind of the device. Okay, and then the third one is a shower head. Shower head is the requirement is 2 gallon per minute. Okay, and then so it also need to have inspection by either the city water conservation representative or a licensed plumber or general building contractor. Okay, and then they need to obtain a water conservation certificate from the water conservation office that certify the modification has been made. Then they are able to sell their house. Okay, and then here comes to industrial. The first part is in the industrial facility, the water is used in different activity, including the washing or rinsing of the raw material, intermediate or final product, preparation or solvent or slurry. And as I mentioned earlier, in Taiwan we have so many semiconductor manufacturing, and actually the semiconductor manufacturing they use lots of water in one day. So that's why these semiconductor manufacturer they try to recover the water because they also want to make sure they have a stable amount of water that they can use. Okay, and then the next is industrial facility in the world have systematically adapt water efficiency measure has reduced water consumption by 20 to 50% and up to 90% if advanced measurement are employed. Okay, and then this is the water saving potential in industrial field. Okay, and then so this is efficiency measure. The first is a closed loop reused. Okay, and then what is closed loop reuse? Closed loop reuse means if you discharge the water and then you try to treat the wastewater and then reuse the water back to your original process. It means you don't discharge the wastewater outside of your industrial. You just keep using this water, so you will have potential of saving 90% of the water. So what is the another 10%? The 10% might be during the treatment. It might be kind of evaporate, or some small portion of the water might be doesn't meet the water quality. So some of the water might be still have to be discharged to outside of the industrial. Okay, and then so the second one is closed loop recycling with the treatment, which is about it might be save about 60% of the water, and then automatically shut off mode is about 15%. And then for the counter current rinsing is about 40%. And then high pressure, low volume upgrade is about 20%. And then reuse of the wash water, you can save about 50% of the water. Okay, and then I remember when I visit one of the semiconductor manufacturer in Taiwan, and then I also take a look about how they try to treat their wastewater and how they recycle their wastewater, the treated water, and so based on the companies based on the manufacturing process, if they purify the water with a really high quality, that water will go back to the washing procedure. For example, if the water is clean enough, they will use this water to clean the silicon wafer surface. And if the water is not clean enough, they will use the water for the toilet, or they use this water for watering the plant or trees. Okay, so based on the quality of the recycled water, they have different application. Okay, so actually this company they try to make a good use of the recycled water. Okay, and then this is the option of for reducing water consumption and enhance water usage is efficiency in industrial. The first one is improve production planning and sequencing. So it adjusts the production process with reducing water consumption. Okay, and then they try. Second is a good housekeeping. They introduce more resource conscious route in operation. The third one is the process modification. So they try to modify the equipment if necessary. So sometimes some of the equipment may use lots of water. Okay, so they try to change the equipment or try to modify the water the equipment. Then they can have similar function, but with less water consumption. And then the next one is product material changes. And you changing raw material usage in production that lead to reduce water demand or less effluent generation. Okay, and then replacing equipment is substitute existing technology with more effective one. So it means try to use a more advanced or new technology with higher wastewater treatment performance, and also it can save the water usage. Okay. Okay, this is another case for the water efficient business. Okay, so this company they try to help the business customer to reduce water usage and lower overhead by lowering water and energy bill. Okay, so this company offer a business customer two types of water efficient audit. Okay, so the first one is a standard water efficient audit. This is an assessment of indoor water use on site. Okay, on site means at home. Okay, and then so the objective of this audit is to save water. And then a utility worker will review the customer's current water consumption and assist identify area where efficient gain can be improved. Okay, so basically the audit include the first one is try to perform a general inspection for domestic water system, and then determine the current consumption pattern, and then assessing the leakage on site. So they try to find out which equipment is leaking the water. They try to identify it. Okay, and then assessing UNRI crystal control mechanism, and then commenting on water management option, and then summarizing total water saving potential. Okay, and then second is called process audit. Okay, and then so if business use water, a process audit can help identify efficiencies. And then the process audit is conducted by this company worker who will analyze water consumption on site. Okay, so this type of the service include these 4 parts. The first one is a site walkover. So one of the experienced worker, they will conduct a detailed observation on site and then identify area of the high consumption over the wastage plus cost saving potential. And then the data analysis. A summary of the site data analysis will be taken, including an analysis of effluent quantity and the concentration. And then mass balances. A site balance will be made that show unidentified losses and the cost of this loss. And then the cost benefit analysis. This will point out the cost saving potential. Okay. And then the third one goes to the building. Okay. So in the US, it is estimated that the building consumes more than 400 billion gallons of the water every day. Okay. And then so the expense of the federal sector for the water and the sewer service reach up to 1 billion. Okay, and then so if achieve water saving about 40%, it will be enough water to supply for 1.8 million population. Okay, and then so this is the case in New York City. The water challenge to a restaurant. They try to help the restaurant owner try to save the water. Okay, so in 2015, the Department of the Environmental Protection Agency, the EPA, in New York City, they announced that the water conservation challenge to restaurant. So 30 restaurants in New York City, they joined this challenge, with each restaurant working to lower their annual water consumption by 5%, and try to save a total of about 3 million gallons of the water every year. Okay, so the challenge provide in the following. The first one is check the restaurant water usage, and then attend 4 workshop featuring green hospitality expert, and then develop a water conservation plan. So it means that this restaurant, they need to come up with their water conservation plan in order to take this challenge. Okay. And then here comes to the agriculture. So there are different types, all different options for reducing water consumption and improve the water efficiency in agriculture, such as efficient aggregation technology, and then our improving aggregation scheduling, regulate deficit irrigation, and the practice to enhance the soil moisture. Okay, as you can see from this picture, they try to water the plant, right? So if they are leaking in this device, so it means the water cannot be distributed to a little bit further area. Okay, so the water may just stay in this area, and then for the plant away, they might. Okay, so it means if the water is in the water distributor, then we will not use the water efficiently. Okay, and also it means we are. Okay, and then weather-based irrigation, you usually use the local local weather condition data to determine how much water a crop needs. Okay, and then so regulate deficit irrigation, and then sprinkler. This is called sprinkler. The sprinkler and dripping irrigation system usually have higher distribution uniformity. Okay, so you need the precise water distribute application of water and the fertilizer to meet the crop's need. Okay. Okay, and then so this is a practice to lower water consumption and the improve water efficiency in agriculture. Okay, so the first one is called dry farming. So what is dry farming? They use a mulch, the mulch to help retain soil moisture for crop to grow. The mulch means the farmer, they try to use kind of material which is the material is made of like made of the wood, like a small piece of wood. Okay, so they will cover this small piece of wood nearby the tree. Okay, and then so this is called mulch. Okay, this is called mulch, and then so this mulch can it can kind of retain the moisture. Okay, so it won't make the tree to dry out. Okay, and then the second is called rotational grazing. So the animal are shift between field to promote the pasture regrowth. So well grazing management enhance the field's water absorption and decrease the runoff, making the pressure more drought out tolerant. Okay, and then the second is called compost and mulch. Okay, so decompose organic matter used as a fertilizer, enhance the water retention capacity, and improve the soil structure. Okay, and then the mulch is a material sprayed on top of the soil to keep the soil moisture and can be made from organic matter that can break down into compost. Okay, so usually the mulch is made from the wood. Okay, and then the next one is cover crops. This soil reduce weeds and then increase the soil fertility. And then cover crops allow water to penetrate to soil more easily, which improve its water holding or water retention capacity. Okay. And then next is called conservation tillage. This need equipment to partially till the soil, but leave at least about 30% of the vegetative crop reside on the surface. Okay, and then help enhance water absorption and reduce evaporation. And then the next one is going organic. Healthy soil is rich in organic matter and microbial life, which serve as a sponge, let absorb and retain the moisture for plant. Also, it reduces the toxic pesticides from entering the waterway. Okay. And then this is a case in New York City that new farmer grant fund program. So actually in the US they try to encourage people try to save the water. So they have so many kind of like a challenge program. And then so if you won the challenge, you will get some reward. Okay. So in the New York State, it has spent about 1 million in the 2018 to 2019 to support beginning farmer who have chosen a farmer as a career. Okay, and then this grant fund will help a farmer improve their farm performability, including advancing in innovative technology that increase sustainable agricultural production practice. Okay, so eligible farmer may receive 15,000 to 50,000 for up to 50% of total project cost. So the rest of 50% must match by the recipients. So it means they try to encourage the farmer try to use a newer device, or try to use a more smarter way, try to do the irrigation, try to save the water. Okay. Okay, here comes the regulation. So there are two types of regulation. The first one is called temporary regulation. The regulate certain types of the water used during a specific time, and restrict the water usage to a specific specified quantity. And then these programs are enacted during water shortage and the ease once the shortage has passed. Okay, so the restriction are established on non-essential water usage. Okay, and then the next is a permanent regulation. Amendment to build requiring the installation of water saving equipment and maximum water use standard for plant process. Okay, and then this is the case. How does the water is regulate for the usage? Okay, so this is the case in Vancouver, in Canada. Okay, so the city of the Vancouver established a water restriction on the use of treating drinking water, and then automatic shut-off device are required on hose for all watering and the water or wash activity regarding of the current level of water restriction. So it means the automatic shut-off device means just like for some of the device, you cannot just open or turn on the device for a long time. It will turn off or close the switch automatically in a specific time. Okay, and then so first one is activity. This is residential lawn watering. The lawn watering means we use the water to watering our garden. Okay, and then for the stage one, for the housing who has an even number. Okay, who has for example like a 2, 4, 6, 8, 10. Okay, so they can use the water on Wednesday and Saturday from 4 a.m. to 9 a.m. You can only in this period of time you can water your plant or water your garden. And then for the odd number like 1, 3, 5, 7, 9, these odd number they can use the water from 4 to 9 on Thursday and Sunday. Okay, and then there's stage 2 and stage 3, stage 4. Okay, so it means in order to not to waste too much water, some of the government they have their own water restriction or some water regulation, because I think everybody knows because of the global warming, we have less and less water right now. So that's why water become more and more important in the future. Okay. And then this is the water utility lead, water conservation and water efficiency measurement. Okay. And then this is the non-revenue water. It is a difference between the amount of water utility pumped into the distribution system and the water that is billed to its consumer. The difference is commonly known as a leakage, and in many cities it can reach about 20 to 50% of distributed water. Okay, so how can they try to they determine the loss? Okay, so the first one is called apparent loss. Apparent loss, this is caused by inaccurate metering, data cleaning error, or legally tapping. Legally tapping means some people they might be change the meter. Okay, so actually this is illegal. So some people they will do in this way. Okay, and then the other one is a real loss. The real loss means the leakage is from all parts of the system and overflow at the storage tank. Okay, and then real water losses are caused by poor operation and maintenance. Okay, and then unbilled authorized consumption. This is the water consumed by flushing, firefighting, and the water provided for free to certain consumer groups. Okay, and then here comes to the reused and recycle. Okay, the definition of the reuse is the reuse of water in a single process, or the use of the collect water for another purpose without treatment. Okay, and then recycle, the definition of recycle is the use of the treated water for another purpose. Okay, and then reuse and recycle water can be used, including industrial process and the irrigation of agricultural land. And then the recycled water can be blended with the surface or groundwater to increase the supply. Actually, this is just like a kind of dilution, because usually the recycled water is kind of clean. So we use the clean water to mix with the surface or groundwater. Okay, we try to mix the purified water with natural water. Okay, and then so this will reduce the economy and the environmental cost related to the establishing new water supply in the development of the circular water economy. Okay, and then this is the water use involve collecting, treating, and reuse wastewater without treatment, and include the reuse of rainwater in houses and buildings. Okay. And then the recycled water, meaning reclaimed water that has been treated and can be reused for industrial process and irrigation. And then so if the wastewater is well treated, it can be blended with the surface or groundwater to increase the supply. Okay. So this is again, so this will reduce the economy and environmental cost. And then so this will kind of match the objective of the circular water economy. Okay. Okay, so what is the benefit of the water reuse and the recycling? The first one is it decreases the diversion of the fresh water from sensitive ecosystem. And then so for the linear economy, the plant and fish depending on the sufficient water flow for healthy habit. So if we have less the flow from the diversion for the agricultural urban and the industrial process, it can cause negative effect to water quality. Okay, and this for the circular water economy, the water reused and recycling can free up huge amount of water for the environment and increase the flow of vital ecosystem. And then the second benefit is reduce the discharge to sensitive water body. Okay, let's take a look at the circular water economy. So the water reused and recycled can be used to decrease the wastewater discharge into receiving water body, enhance the ecosystem health. And then the other benefit, it can be used to enhance wetland or repairing habitat. Okay, so the water flow can be enhanced with reused and recycled water to enhance and improve the aquatic wildlife habit. Okay, and also the most important part is it can reduce and prevent the pollution. Okay, because we are recycling the water. Okay, and then so reuse and recycled water can be used in other locations. For example, the recycled water containing higher level of nutrient can be used for the agriculture. So it means the high level of nutrient, actually we can use it as a fertilizer. Okay, so this is just like one of some of the company in Taiwan. They try to do in this way. They try to recover some nutrient from wastewater, and then they try to purify it, and then use it as a fertilizer. Okay, so it means when you remove the nutrient from the water become clean. The water can be reused again, and then the nutrient can be recovered. Okay, so it means there is no waste discharge, right? Okay. Okay, the next one is save energy. Okay, So for the circular water economy, reusing and recycling water on site or nearby reduce the energy required to distribute water. Okay, because if when the wastewater is treated in wastewater treatment plant, and then this wastewater treatment plant they need to discharge, they need to distribute the water to all the place. So they will use lots of pump or use lots of machine. So if in some industrial, if they can reuse the water on site, then they don't need to use lots of water from the wastewater treatment plant. So the wastewater treatment plant they can save some energy, try to distribute water to the industrial. Okay. Okay, and then this is the water recycling involve the recombination and of the water from wastewater for non-potable or potable use, which can be supplied back to the water system. And then water for recycling can come from the centralized system or from the small on-site system. Okay, so it depends on what your purpose. In Taiwan, some of the industrial they try to recycle they try to treat their wastewater and recycle the water, and then they use in their company. Okay, so this is just like a small on-site system. Okay, and then so for example, the recycled water can be used for a variety of purpose. Okay, including agriculture or landscaping irrigation or industrial processing or toilet flushing. Okay, so there are so many purpose. There are many purpose of the recycled water. Okay. Okay, and then this is industrial reuse water and recycling. So industrial water can be reused. So it means that the wastewater is reused directly or recycle. Recycle means the water is treated before reused. Okay, and then within a business itself or between the several business. And then this is direct reuse within a business. A business can reuse wastewater directly that is clean enough for the purpose of being used. Okay, and then the processed water is produced by industrial procedure, such as cooling and heating, and this type of the water usually contain a few contaminants after use because they have already treated. So that's why that is why the water is much more purified. Okay, and then the cooling tower are one of the most common technology used by industrial, and they are used for washing process. Okay, so the manufacturing they treat the wastewater and recycle it. They can use this treated water to wash their, for example, to wash their product or to try to clean their the surface of the material. Okay, and then this is direct wastewater reuse. It can be performed between business with the exchange of the wastewater material for the mutual benefit of two or more business, known as industrial symbiosis. And then so the all members receive a benefit from industrial symbiosis by reducing the input in their product process, for example, the water, or by reducing the cost of wastewater treatment. And then the industrial symbiosis occur through the exchange of byproducts, sharing the management of utilities and the ancillary service. And then so direct reuse of wastewater in industrial symbiosis include the exchange of the processed water from one business to another. Okay, and then this is the treat and the reused. So if wastewater is not suitable for direct reuse, the decentralized wastewater treatment system will be needed to reduce the contaminant to a safe level for reuse. And this can be done within a business for its own reuse or between business. The specific treatment options are dependent on the quality required at the end. The water used for irrigation may be treated in a constructed wetland, while membrane filtration and the activated carbon process can generate the treated wastewater with a higher quality than the fresh water. Okay, so it means if you recycle the water and you are hoping that you can have the high purified wastewater, then you can add it more advanced wastewater treatment technology. For example, like a membrane filtration or activated carbon absorption. Okay. And this is the benefit of industrial water reuse and recycle. There are many benefits of industrial water reused and recycling, including reducing the freshwater cost and the increased operational efficiency, reducing the water flow and the increased production performance due to the increased availability of the clean water. And then agricultural reuse. The use of recycled water for irrigation is managed by regulation that control the treated water quality. Because if you wanna use recycled water to do the irrigation, we need to make sure the water is also is clean enough in certain level. Because if the water still have some contaminant, or if the water still have some pollutant in it, you use this water to water the plant or to do the agricultural purpose, then for example, the vegetable they will uptake or absorb some of the contaminant, and then so when we eat the vegetable, then it means we will have we will also intake the pollutant into our body. Okay, and so the reuse and the recycling of the wastewater in agriculture provide many advantages. The first one is conserving drinking water supply, and then reduce stress on natural water body, usually used for extracting irrigation water, and then recycled water containing value, nutrients, reducing fertilizer needed, and then reducing discharge to the natural environment. Okay, and then so reused for urban agriculture. So what is the urban agriculture? As you can see from this picture, the urban agriculture means they try to grow the plant in the urban area. Okay, so as you can see, there are so many buildings here. This is just like a farm in a city. Okay, so with the rapid urban urbanization, many cities are facing water shortage and the rising food insecurity. Because if we have less water, it means we will also have less water to do the irrigation. So we are not able to plant the vegetable or to plant the trees, right? And then so in water reuse in urban agriculture provide a year-round supply of water and providing food, income, and employment opportunity to city, and then improve the urban landscaping, and then reduce the pollution load on downstream water source. Okay, so this is the case for the purpose of recycled water in Queensland, in nearby New York City. Okay, so under the program, there are 4 types of the recycled water. The first type is called Class A plus recycled water. This is the highly treated recycled water, okay? And this water is usually only required for industrial process water. For example, clean the silicon wafer. This is especially for the semiconductor manufacturing because they need a highly purified water to clean the silicon wafer surface to make sure the surface of the silicon is clean enough. Then they can move to the next step. Okay, and then the second and third is for class A and class B recycled water. So this usually require additional treatment process than the traditional sewage treatment process that are sufficient to allow the effluent to be discharged to the environment. Okay, and then the last one is class C. This is the lowest quality of recycled water supply by the Queensland Urban Utility. Okay, so next is called potable water reuse. So for the potable water reuse involve the use of the domestic wastewater as a source for the drinking water. And then so there are two types of planned potable reuse. The first one is called indirect potable reuse. The second type is called direct potable reuse. So the indirect potable reuse is the recontamination and the treatment of the water and the eventual return back to the current natural water recycle well upstream of the drinking water treatment plant. And then this is a direct potable reuse. Direct potable reuse is the injection of the recycled water directly into the potable water supply distribution system. This means the water reused by consumer could contain either undiluted or slightly diluted the recycled water. And the main differences of the indirect potable is potable reuse is that there is no temporal separation between the recycled water introduction and its distribution to the consumer. And then this is managed aquasphere recharged. Okay, aquasphere is the layer underground. Okay, just as you can see from the picture, this is aquasphere. Okay, and then so aquasphere are the rock formations or sedimentary deposit porous enough to hold water in place. The porous means the surface of the rock, they are irregular. They have an irregular shape. Okay, so the irregular shape, they are able to hold the water. Okay, so most aquifer are naturally recharged by rainfall or other surface water that infiltrate into the ground. However, some area where groundwater use is greater than the natural recharge rate, aquifer will be depleted quickly. Okay, so manage aquifer recharge consists of the water management method that recharge an aquifer using the surface water. Okay, and then two approach used to recharge the aquifer. The first one is deep injection, and the second is surface infiltration. The deep injection method put excess water directly into the aquifer using the well. So as you can see, this is the well. Okay, so they just inject a lot of water into the aquifer. Okay, try to keep the water in the aquifer, because if there is less water under the ground, then the soil, they will kind of collapse the soil will collapse because there is nothing underground, so the soil will just collapse. Okay. And then the surface infiltration involve the creating an artificial stream in fast draining soil, and then also creating a local catchment system for the rainwater. And existing managed aquifer recharge project rely on river, stormwater, and the treated wastewater. The treated wastewater provide the most consistent supply. River is generally only available for aquatic recharge during the winter period. Okay, and then the stormwater is a common source for aquifer recharge project, as it decreased flooding and the capture water that is lost as a runoff. And then this is environmental reuse. Environmental reuse is the use of recycled water to support the wetland and to supplement stream and the river flows. The wetland provide a debt benefit, the wildlife happy, water quality improvement, and flood diminishment, and the fish breeding ground. And for the waterway that have been impaired or dry from the water diversion, water flow can be enhanced with the recycled water to sustain and improve the aquatic and the wildlife habitat. And then this is urban reuse. In the urban area, on-site non-potable water systems are used to meet non-potable needs, such as cooling the building, irrigating the landscaping, and flush the toilet. Okay, and then this comes to black water. So what is black water? The definition is the water from the toilet. This is we call black water. Okay, and then the black water contain urine and then extract. After the flush the black water into the municipal sewer system, it is directly transferred to a facility for further treatment. So the average person generates 1.5 liter of the waste per day. And then so in the black water recycling system, all the black water is directly to an initial tank by gravity. The black water then goes through an aeration stage, a sludge settling process, before it is chlorinated and used as irrigation. So the chlorinate process means they try to use chloride, as a agent, try to kill the bacteria. Okay, so they will try to chlorinate the water, and then when the water is treated, then will use as irrigation water. Okay, and then this is the benefit of black water recycling. The first one is we will have energy conservation. The removal of the harmful bacteria from black water is energy intensive. The second is water conservation. Use recycled black water to water lawn and the non-food garden, assist conserve potable water. The third is resource conservation. Plants that are grown using recycled black water do not need fertilizer, as the water is nutrient rich already. And habitat protection. The recycling black water reduce the chance of the wastewater entering the water body and damaging the natural habitat. And then the rainwater harvesting. The rainwater harvesting means just like we try to collect the rainwater, okay, and then store the rainwater for the future use, okay. And so there are two types of the rainwater. One is called a passive harvest harvesting system. Okay, this is typically like a small volume system. Okay, and then so the other one is activate harvesting system. This is a larger volume. Okay, the difference is in the size. Okay, the storage size. Okay, and then this is the benefit of the black water harvesting system. The first benefit is reduce the impact of urbanization on watershed hydrology. So it will reduce the runoff volume from the site, or reduce the flooding in downstream water, and increase the groundwater recharge. And it has lower pollutant load to the downstream of the receiving water. And also, for the second benefit, it will reduce the stress needed for the additional infiltration. Okay, so it will increase the efficiency of the stormwater infiltration. Okay, so here comes to the recovery. The recovery is the wastewater treatment facility in the circular water economy offer multiple opportunities, such as generating renewable energy and recover nutrient. And in addition, the infrastructure structure of the water and the wastewater treatment facility, it provides a numerous opportunity to generate renewable energy. Okay. And then in the circular water economy, wastewater treatment plants are not waste disposal facility. Okay, so the wastewater treatment plant is just like a place try to purify water, but it also try to recover the material from the wastewater. Okay, and then the wastewater treatment facility are the resource recovered to produce the purified water and generate renewable energy and recover a nutrient. In addition, the facility and the infrastructure of water and the wastewater treatment facility provide opportunity to generate the renewable energy. Okay, and then this is a renewable energy generate technology at wastewater treatment facility. Okay, the energy generated from the wastewater treatment is a renewable energy resource, such as electricity energy, heat or biofuel from utilization of digested gas. Okay, and then the electrical energy and the heat from thermal conversion and biomass. And then the third, the electrical energy from biosolid product used by another entity. And then anaerobic digestion is a series of biological treatment process, so that the microorganism break down the biodegradable material in the absence of the oxygen. So final product is a biogas and can be processed into renewable natural gas and the transportation fuel. So it means during the wastewater treatment plant, when we treat the wastewater, sometimes it will form a kind of a biogas. So we can collect the biogas, try to convert it into the electricity. Okay, and then so the wastewater treatment plant facility employ anaerobic digester to break down the sludge and reduce the bacteria in the wastewater. Okay, and then so the biogas can also be upgraded by removing the CO2, nitrogen, or oxygen in order to comply the BTU requirement for the pipeline injection or compressed biomethane vehicle fuel. Okay, and then this is the case in Germany. They try to collect the biogas. Okay, so in Germany, this city has a 10 digester tower, which has a total volume of 80,000 cubic meter. So it contains large lead rod continuously at a temperature of 36 degrees Celsius. So under anaerobic condition, about 95,000 cubic meter of digester gas is produced every day. So this gas is converted into electricity on site and used or is fed as a biomethane into the urban gas network. Okay, and then this is the wastewater treatment facility of the renewable natural gas project. Okay, so in Poland, this wastewater treatment plant, they try to recover, they try to collect the natural gas. Okay, they try to collect the biogas, they try to collect the biogas and then convert it into a renewable natural gas. So the biogas, the methane, will be sent to the process on site. Okay, so this project will cut the greenhouse gas emission more than 20,000 tons every year, and it will generate more than 3 million in revenue annually, and replace 1.34 million gallons of diesel fuel. Okay, so actually, when for this project, when they try to recover the biogas and convert it into the natural gas, they can make some good money. Okay, so they try to come up with the way, try to goes to the circular economy process. They try to recover the biogas and then sell, and then make the biogas become a valuable material. Okay, and then so this valuable material that can be sold in the market. Okay, and then this is the thermal conversion of the wastewater and biosolid. And the process of the converting biosolid to energy through the anaerobic biodegradation through the thermal conversion. And then so high temperature of the thermal oxidation is well established technology. Okay, there are some benefit. The first one is reduction in biosolid. Okay, and then the second is generate the heat for the use, and then reduction in facilities overall carbon footage, and then lowering the reliance on fossil fuel, and then generation of the ash for use the building or material. So the ash, we will talk about the ash later. Okay, so they will use this ash to make us the kind of concrete or the brick, try to make the house. Okay. And then this is the case in Hong Kong. The Hong Kong, they try to use the waste to produce the energy. Okay, so the Hong Kong, it has about 3 million cubic meter of the wastewater, which equal to more than 1,200 tons of the sludge. Okay, so this plant has the capacity to treat the maximum of the 2,000 tons of the sludge every day, and then with the heat generate, recover, and turn it into an electricity that can meet the demand of the whole family. Okay. So the important part is so after it running at a full capacity, the facility can provide higher than 2 megawatts of the excessive electricity to support about 4,000 households. So after the incineration, the sludge is converted into ash. It can be either decomposed in a landfill, or it can also be used for building a house. So actually, it will reduce the emission of the greenhouse gases by up to 237,000 tons annually. And this is the thermal energy recovered from the wastewater. The thermal energy can be recovered from the raw wastewater or effluent by exploiting the significant temperature differential between the wastewater and the ambient condition. And these temperature differences can be recovered for the use in heating and the cooling system, which is often used for the building at the facility and the building and of the area around the facility. Okay, and then this is the case in in Germany. Okay, and then this company is supply the energy with a specific wastewater pressure line found burning. Okay, and then so this water is about 12 to 15 degrees Celsius and stored in the whole year. Okay, so in the winter, the special heat pump will withdraw the heat from the wastewater, and then the water around to 35 degrees Celsius, and then transport to the floor, heating and radiant ceiling panel. Okay, so they try to warm the water to 35 degrees C, and then try to use the water, try to warm the whole facility. Okay, and this is the traditional renewable energy at wastewater and at water and wastewater treatment facility. And then the facility, the utility perform traditional renewable energy activity on facility-owned buildings such as solar radiation or flow solar photovoltaic system, or wind power, or energy recovered by hydropower, or nitrogen and phosphate recovered from wastewater, or land application, or plastic, or brick, or mining wastewater for metal. Okay, and this is the solar radiation capture at facility. So the solar photovoltaic system convert the sunlight into electricity using solar panel. Okay, and this system can generate a significant quantity of electricity, and depending on the quality of the sunlight and the system of the mount panel. Okay, so as you can see, this type of the solar panel is commonly used in my country. Okay, because we try to try to save some and try to reduce the pollution and try to save the energy. So right now we try to have more solar panel, in order to use the clean energy. Okay, and then the PV system can be installed on a rooftop to save the land space. Okay, and this is the case in Australia. Okay, in Australia, they install the solar panel on the on the water treatment facility. So the first solar system installed on the roof of the water utility tank. Okay, so right now the solar system is part of the utility pledge to achieve net zero emission by 2050, and then with the interim target of 40% reduction of 2025. And then the system costs about 125,000 and have a payback period of 7 years. So it means when they build the solar panel as their renewable energy, it will takes about 7 years, and then you can start it to make the money. Okay, and then so it is estimated operation life of 25 years. Okay, so after 7 years, you will make some money because of the solar panel. Because of the solar panel, they try to collect the sunlight as the energy, and then they can convert it into the electricity. So in Taiwan, some of the electricity comes from the solar panel. They can also be sold. They can also be sold to electricity company. Okay, so that's why our government try to encourage the family or some industrial try to have their own solar panel. Okay, so if the solar panel generate enough the electricity, that you can sell the electricity to the electricity company. Okay, and this is the floating solar photovoltaic system. This system is called FPVS. This means they install the solar panel like in the ocean or in the river. Okay, so this is just the different they just install the solar panel in different places. Okay, this is the most differences part. Okay, and then here comes to the wind power capture facility. The wind energy can be captured using the wind turbine. This is the wind turbine. Okay, this is wind turbine, and then so it is cost effective in area with enough wind resource. And usually we have this wind turbine near the ocean in Taiwan. So if someday if you have chance to visit Taiwan, you will see a lot of the wind turbine near the ocean or near the ocean coast. Okay, because usually they are more, the wind are more strong. So when the wind is a little bit stronger, they can use the advantage of the strong wind to convert the wind into the electricity. Okay. And this is the case in Germany. They use the wind turbine to generate the electricity. Okay, so as you can see, there are so many cases is from Germany. Okay, so because Germany is the country in Europe, they are more they try to come up with more solution to protect our environment. Okay,
Mr. Chin,
yes.
Can we
Yes.
break for the 5 minutes maybe?
Oh yeah, sure. Yeah, sure.
Maybe
Okay.
to prepare for the drink.
Okay. So we take about 10 minutes or 5 minutes.
Okay.
10 better, Pak Ching.
10 minutes. Okay.
10 minutes. Okay.
Okay, 10 minutes.
So the student can show up the all. So in the all videos, we need to shoot the camera shoot to get the video.
Okay, and then I will be come back in 10 minutes.
Okay.
Okay, see you later.
See you.
See you. So the student not show in the video anymore. Si belum Bu Dwi belum ya? Bu Dwi, Ika, Arif masih banyak yang belum. Coba di open apa videonya. Farhan, Sri udah, Lara Ismano, Where is the Lara Ismano Fitri?
Present, Pak.
Please show up your video ya.
Okay, I am present, Pak.
Mutia, Laisa Hus, mana Laisa? Budi, Rika Permata, Ari Aditya, ada videonya. Rika Permata belum ya? Budi ada Budi. Hernanda, can you show up the video please? Hernanda, okay. Get the camera. Okay.
Mungkin yang belum absen, silakan isi absennya Pak Idral.
Pak, katanya problem email mereka, Pak. error passwordnya katanya banyak. Bisa di enable yang ini Pak, yang bebas email itu.
Oh iya, boleh Pak.
Oke Pak, makasih.
Ini pasti diedit.
Hernanda dengan Permata nggak ada ya?
Nanti ya gitu.
Hernanda dan Permata belum ada. Pak Thompson? Oke,
Rika Permata ini kayak sepertinya mahasiswa dari Minci, Pak.
Rika Permata.
Iya,
Oh itu.
yang ini yang menjadi asisten untuk dosennya.
Oh gitu. Oh, iya. Indonesia ya? Namanya Indonesia nampaknya Bu. Jadi, kalau Budi nggak ada juga. Budi Ernanda, oh, Budi ada. Kalau Lara Ismano, Pak Thompson tadi mana Pak Thompson? Oke, saya foto sekali lagi ya. Oke, silakan take a break for the 10 minute ya. Sampai jam berapa nih? Sampai jam berapa Bu Fitri?
248 2048
20.48 ya.
ya
Oke.
Pak.
Oke. Okay, Mr. Chin Lung Chen,
Yes.
we can start again.
Okay, thank you.
Okay, please.
Okay, can everybody see the points, the PowerPoints right now?
Not yet.
Not yet.
Not yet.
Okay, let me try again. Okay, can anyone see the PowerPoints right now?
Yes.
Okay, got it.
Okay. Okay, we see this.
Okay, okay. So right now we go to the nitrogen and phosphate recover from the wastewater. So the use of the nitrogen and phosphorus-based chemical fertilizer, it shows the increasing trend because in Taiwan, we try to we will have lots of agricultural activity. So that's why the fertilizer we have been used huge quantity every year. And then so this will cause a large scale influx of nitrogen into the environment. Okay, so it will impact the environment. And so the phosphorus is at the risk of the depletion because actually the phosphorus is a kind of natural resource. So if we just use the phosphorus without recovering, so one day we may use up all the phosphorus. Okay, so therefore the recover and the reuse of the nitrogen and the phosphorus are needed. Okay, and this is a nitrogen recover. So nitrogenous material exists in the sewage. It can remove from the sewage effluents and convert into the biomass through the secondary process. Okay, and then the fertilizer can be produced from the high ammonia nitrogen concentrations side stream from the starch digestion and processed by a stripping absorption process. And then the stripping of the ammonia can be achieved by stream or air. Okay, and then the zeolite and the clay is usually used to absorb the ammonium. Okay, so this is the absorbent people commonly use. This is called zeolite and clay. Okay, and this is the case, the wastewater treatment facility in Oslo they try to recover the nitrogen. Okay, so this wastewater treatment plant in Norway, they cooperate with other company. The company is producing the fertilizer. Okay, so the wastewater treatment plant, they recover the nitrogen, then they sell the nitrogen to the company, and then the company use the nitrogen to produce the purified fertilizer for agricultural usage. Okay, and then so it's around about 12 to 15% of the total nitrogen loaded enter to the plant is recovered. Okay, and then so after the anaerobic digestion of the starch or lime conditioner or field pressing stage, the ammonia stripping and the following capture of the ammonia gas with a concentration with a concentrate nitric acid solution. Okay, and then the stripping and the scrubbing treatment generate the ammonia and the nitrate. And as part of this circular business model, this company supply the nitric acid and receive the ammonia and nitrate, while the wastewater treatment plant benefit from a safe, efficient solution that lower the operation cost because they can sell the nitrogen to the company, so it will lower their operation cost. Okay. And this is the phosphorus recovery. So there are two possible ways to recover phosphorus from municipal wastewater. The first is recover from wastewater treatment and recover from the produced sludge. Or they can recover from the sewage sludge, such as magnesium and ammonia phosphate, or calcium phosphate, or iron phosphate. Okay. And then this can be separated from wastewater due to its specific gravity. And then the phosphorus can be recovered from the sludge by the supercritical water oxidation, which is the destruction of the organic in sludge. And then the most process involved in the recovery of the phosphate product require a chemical consumption. The crystallization is one technology that is highest percentage of recover resource of phosphates, which has about 90% of recovery rate. Okay. And this is the case of the nutrient recovery. Okay. The city in Canada, they try to eliminate the build-up of the cement-like material in the wastewater treatment device. And then it can eliminate the material will prevent a significant recurring maintenance and the repair cost. Okay. And then so this facility will recover the phosphorus and nitrogen from the wastewater and turn it into a high purity, environmental friendly fertilizer. Okay. So it means based on their wastewater treatment process, the nitrogen and the phosphorus has been recovered. Okay. And then so the city will produce about 240 to 350 tons of the fertilizer every year from the wastewater. Okay. So it will be able to be blended with other fertilizer product with soil type of agricultural application. Okay. So as we can see from this case, the nitrogen and phosphorus has been recovered from the wastewater. So it means we try to remove some of the nutrient and then make it as a valuable material. So it means that we remove some product which is kind of harmful to our environment, and then we try to purify it and then use it as a fertilizer. Okay. And then this is the land application of composting biosolid. So the wastewater treatment plant generate the effluent that is discharged into the water body. That must be controlled in environmental responsible manner. Okay. So the turn of the biosolid and sludge is a nutrient-rich organic material resulting from the treatment of domestic sewage in the treatment facility that can be recycled and applied as a fertilizer to improve and maintain productive soil and stimulate plant growth. Okay. And here comes to plastic. So one of the new technology under development is the production of the biodegradable plastic, because in Taiwan, we use too many plastic material. For example, plastic bag. Usually, when we go to the supermarket, we will use the plastic bag to hold our fluid or hold our the product we purchase in the supermarket. So we use a lot of plastic, but actually the plastic, they are non-biodegradable. So it means if you put it into a landfill, even though like 100 years, the plastic bag is still over there. Okay, so that's why right now we try to develop a technology, try to make a biodegradable plastic. So this biodegradable plastic usually is contain carbon, hydrogen, oxygen, and nitrogen. And then so the the biological wastewater can be used to make the polymer. Okay. And then brick. And then so the sludge is the byproduct producing during the incineration of the sludge in the incinerator. So the sludge ash is primarily silty material with the same size of particle. So this type of the product can be used to build a house. okay, because it has the similar ingredient with the brick. Okay, so in the circular water economy, ash from the sewage sludge incineration can be used to in the brick and the tile industrial. Okay, so it means the ash or the sludge after high temperature of the burning, we can sell it as to a brick or a tile industrial. Okay, and this is the case. They make the brick from the recycled sewage. Okay, and then so based on this case, this company, they create a brick with the ash and react and mix with the carbon dioxide, water, sand, and a small quantity of the salmon to form about 70 kilogram of the blocks. Okay, so it means they use the remaining ash after the burning. They use it to make the brick. And this is the mining wastewater for the metal. The metal can be recovered from the wastewater. So as I mentioned earlier, usually in the past, we try to remove the heavy metal from the wastewater. Okay, and then so actually the heavy metal is still there. So right now we try to not remove, we try to separate the metal with the water. And then we try to collect the metal. Then we purify it and then sell it in the market. Okay, so this it means we will kind of recover not just recover the water, we also recover the metal. For example, the silver and the cadmium are increasing being found in the wastewater, and then it's worth to do the recovery due to the market value. Okay. And this is the case on the brick from the recycled sewage. Okay, so in the Netherlands, there is a large scale. There is a large scale demonstration of the zero brine project that try to prove the mineral such as magnesium in the clean water. So actually, in this project, they try to recover some of the magnesium. Okay, and then so and then they try to recover it and then sell it into the market. And then so they call this project zero liquid discharge, ZLD. Actually, this is a kind of a new term in the wastewater treatment process. Okay, the zero liquid discharge means we didn't discharge any of the wastewater outside of the company. We try to recycle we try to treat the wastewater and recycle it over and over, and then the water just keep circulate in the company. Okay, so this is called zero liquid discharge. And then this comes to circular economy in wastewater treatment aspect. So in industrial wastewater treatment, recycle and reused, this is the typical water used in the chemical industrial. For the reagent, the quantity is low, but the concentration is very high. Especially in, for example, if for the semiconductor manufacturing, they use the hydrogen fluoride to clean the silicon wafer surface. They try to do the aging, so they use the higher concentration of the hydrogen phosphate, hydrogen fluoride to try to use as a reagent. Okay, and then the solvent, and then cleaning agent. Okay, and then cooling water. Cooling water, they use lots of water to cooling the some of the equipment, and also the boiled water. And this is one of the case. People use the TiO2. They use the TiO2 based advanced oxidation nanotechnology for the water purification and reuse. The TiO2 is referred to the titanium dioxide. Okay, the TiO2, the titanium dioxide, is kind of popular in the recent years, because TiO2 is, people call TiO2 is kind of a green material. Okay. And then so what is advanced oxidation technology? We call AOTS. The advanced oxidation technology are the most emerging chemical oxidation process and play an important role in water treatment. So the AOT is the set of the chemical treatment process designed to decompose the organic and inorganic material in water by oxidation process. The AOT technology are able to destroy biological toxic and non-degradable chemical in water, such as amortic, pesticides, or volatile compound. Okay. So there are a few advanced oxidation technology. The first one is called chemical oxidation. The chemical oxidation usually we use on the ozone and the hydrogen peroxide. Okay. And there is one famous technology which is called Fenton, or photo-Fenton process. Okay, so for the Fenton process, they use a reagent which is iron 2 mixed with hydrogen peroxide. So it will produce the hydrogen radical. So the hydrogen radical is very activated. So it will try to kind of decompose the pollutant in the water. And then for the photo-Fenton, it can refer to the light. So they use the Fenton reagent plus the UV lights. Okay. And then there is the other UV-based process. And then this is called a photocatalytic reductive process. This is like a semiconductor. They use the TiO2, the titanium dioxide, and then with the UV, try to oxidize the contaminant in water. Okay, and then the other one is sonorless. We use ultrasonic. We use the ultrasonic process to try to oxidize water. Okay, but actually the sonolysis, this process actually work very well, but actually it uses a lot of energy. Okay, and actually this device is very noisy. Okay, and here comes to the Fenton process. Fenton process is a name of a scientist. Fenton, this person invent a reagent. So that's why we call Fenton reagent. Okay, so the Fenton reagent, just like I mentioned earlier, we mix the iron 2 with the hydrogen peroxide. Okay, so when we mix the hydrogen peroxide, it will produce the hydroxyl radical. You produce the hydroxyl radical. The hydroxyl radical is very activated, so it will kind of attack the pollutant in the wastewater. Okay, so we use the hydroxyl radical, kind of use hydroxyl radical to clean the wastewater. Okay. Okay, as you can see, this we use the iron 2 and hydrogen peroxide, so it will produce the hydroxyl radical. Okay, so this is called Fenton reagent. Fenton reagent is the iron 2 mixed with hydrogen peroxide. Okay, so you will generate the hydroxyl radical. Okay, so this is the Fenton process. The Fenton process is just you will generate a radical like a hydroxyl radical. And then the radical will attack the organic contaminant in water. Okay, so when you attack the organic compound in the water, it will be the contaminant will be broken down, and then it will form a stable intermediate, and then it will be mineralized to other final product. Okay, and then this is the TiO2 photocatalytic process to green chemistry and engineering. The photocatalytics has expanded recently due to the discovery of photocatalytic of TiO2. The TiO2 can generate the hydroxyl radical in the presence of the UV. Okay, and then so the TiO2 photocatalytic is getting attention due to its environmental friendly feature. And But however, the process can completely oxidize organic contaminant, non-selective. So non-selective means the hydroxyl radical, it will attack all the organic compound. And on the other hand, selective means for example, the agent, they will attack organic compound specifically. Okay. Okay, and then so the photolysis is the chemical reaction. That chemical compound is broken down by the high proton energy provided by the UV. Okay, so there are different types of the UV that we used to use with the TiO2. Okay, and this is comes to the cost. The cost including the capital cost, operation cost, and maintenance cost. The capital cost can be reduced by design efficient system, and then the operation cost depends on the type of the concentration of the pollutant, level of the treatment, and catalysis load. And it requires the pretreatment, okay? Because the TiO2 has to be used with the UV lights. It has to be UV lights. So if the water it has too much turbidity, so it means the water is kind of too many suspended solid in the water. So the UV light is not able to penetrate the water. Okay, so that's why for the TiO2 process we need to do the pretreatment. And this is the common wastewater treatment technology for variable material recovery. And actually, this is one of my my interesting area. Actually, I'm working on the metal recovery in wastewater. Because the reason I'm trying to recover some metal because usually people all just think, okay, I just want to remove the metal, but they didn't think about the value of the metal. And then so right now I have a small team to work on the metal recovery from wastewater. Okay, and we are using the electrical chemical process try to collect or recover metal in the wastewater. Okay, and then so actually there are so many methods or many technology can be used to recover the metal. The first one is called membrane process. The membrane process includes the reverse osmosis. The reverse osmosis is called RO. And also the next one is electrodialysis and the reverse electrodialysis. Actually right now I'm using the electrodialysis method. Try to treat the wastewater and also try to recover the metal using the electrodialysis. And the next one is called forward osmosis. And then the fourth one is narrow filtration. And then here comes to the thermal process. The thermal process is also called the multiple effect evaporation. Actually, this thermal process they work very well, but actually this process is very expensive because we need to heat up the wastewater. So it means we need to use a high temperature device, try to boil the wastewater, try to make the wastewater to evaporate. So actually this is kind of very expensive process. So that's why for the thermal process right now it is kind of like not practical in industrial purpose. Okay. And here comes to the zero liquid discharge. The zero liquid discharge is kind of new term. Okay, it's kind of new term. So zero liquid discharge is a concept and a technological challenge recently spent in the desalination industry. So the zero liquid discharge is to eliminate the brine discharge while recover water and the salt at the same time. So it means they recover the water and recover the salt. So there is no anything to be discharged. Okay. So in the past, the zero liquid discharge is based on the thermal process. Okay. So that's why the zero liquid discharge is not so practical because it is too expensive. However, right now people try to use other methods to perform the zero liquid discharge process. For example, they use electrodialysis. Okay, so using the electrodialysis will be cheaper than using the thermal process. So that's why right now the zero liquid discharge, this type of technology is kind of getting attention nowadays. Okay, so when the water is recovered and the residual salt is either reused or disposed at the landfill. And then so the costs are high, and then the regulatory incentives are necessary for zero liquid discharge implementation. Okay, so this is one of the case people try to recover the wastewater. Okay, so they use the multi effect evaporator. Okay, so this is the device it connect to the wastewater treatment process. Okay, so as you can see from this picture, they try to recover they try to recover the sodium sulfate. Okay, so they try to recover the sodium sulfate from the wastewater. So this sodium sulfate is very high purity. So actually they can sell this with a good price. Okay, so when you sell something with a good price, it can kind of compensate your wastewater treatment cost. It will lower your wastewater treatment cost. Okay. Okay, so this is the reference of these PowerPoints. And again, I would like to just briefly introduce our master program. For the first semester, you will take the special topic seminar and the research method, and then the environmental, physical, chemical treatment. Okay, and then for the second semester, you will take the special topic seminar, and also technical writing and environmental biological treatment. And this is for the elective subject. Okay, so this is all the elective subject that our master degree student they are able to choose based on their interest. Okay, so the total credit required is 30 credits, and it require the required courses we need 12, and then for the elective courses you need 18 credits. Okay, so this is basically our requirement for master degree student. And then okay, thank you for listening. Thank you very much.
Okay, thank you very much, Mr. Chin Lung Chen.
Thank you.
So this time, Indonesian time, 9 past 10. So how about this? In any question and answer?
Okay. Hello.
Oh,
Hello. Can
hello.
you hear me?
This answer for this question.
Yes.
Yes, I can hear you.
Oh, I'm sorry because the connection is a little bit. The connection is a little bit slow. Okay. Okay. I'm sorry. Can you say again, please? Say the question.
Okay. This so many question in the chat room.
Okay. Yes.
Is it we are discussing it this time, or maybe we can we can answer from the Google Classroom.
Yes,
And-
yeah. Actually, I for the first meeting, there are some of the question in and then
Yeah.
you have already upload to the Google Classroom, and I also answer the question, and I also upload to the Google Classroom already. Okay. So, yes.
Okay.
Mhm.
Okay. Okay. So if no question anymore, and will be the answer by the Google Classroom. So the
Okay.
class by this evening session will be closed at this time,
Okay.
Mr. Ching.
Okay, got it. And
Okay.
I hope that you enjoy the class.
Okay. So, Bu Fitri, you have any closing ceremony, Bu Fitri, for this the second week of this class? Or Prof. Saiful maybe?
Okay, Pak Idral.
Yeah.
Thank you for this moment.
Thank you.
For this, the second time for this class, this the end of class of Dr. Chen.
Yes.
Okay, thank you very much for the very interesting lecture. Actually,
Oh, thank you very much.
Yeah, hopefully we will be continuing for the other professor lecturer for the next week.
Yes.
Thank you very much. Good night.
Okay. Thank you very much, everybody. Thank you. Thank you very much. Thank you, Professor. Thank you.
Thank you.
Okay. Thank you. Have a good night. Bye bye.
Thank you.
Bye.
Okay,
Thank
good
you.
night.
Good night.
And all students can leave the meeting. And I would like to thanks for this attention and apologize for any mistake during the class. And I will finish the class. Assalamualaikum warahmatullahi wabarakatuh and good evening.
Thank you.
And see
Assalamualaikum.
you next.
Thank you, Kak Idra.
Thank you, Pak.
Iya Pak, good evening.